Bismillahirrahmanirrahim. Assalamu alaikum. In today's lecture, we are going to discuss multiplexer and demultiplexer. What is a multiplexer? A multiplexer is a device that allows digital information from several sources to be routed onto a single line for transmission over that line to a common destination. Basically, multiplexer is a combination logic circuit that has maximum of 2 raised to power n data inputs, n selection lines and single output line. One of these data inputs will be connected to the output based on the values of selection lines. Multiplexers are also known as data selectors. Example of multiplexer: 4x1 multiplexer and 8x1 multiplexer. 4x1 multiplexer has 4 data lines, 1 output line and 2 selection lines. 8 line into 1 line multiplexer has 8 input lines, 8 sources, data sources, information sources, 1 output line and 3 select lines. 4x1 multiplexer. A 4x1 multiplexer has 4 data inputs: D0, D1, D2 and D3, 2 selection lines S1 and S0 and 1 output Y. So this is a block diagram of 4x1 multiplexer. So we have 4 input lines: D0, D1, D2, D3. These are the 4 sources, and the purpose of multiplexer is to route information, to take information from a source and to transmit information of that source to this single line. So this single line carries information from D0, from D1, from D2 and D3. So which information of these sources will be routed to this single output line? It will be decided by these 2 select lines. These 2 select line will decide the states of these 2 lines, will decide whether D0 data and D0 will go to the output, or data and D1 will go to the output Y, or data and D3 will go to the output line Y. So this line will be used by either D0, D1, D2, D3, depend upon the combination of these 2 select lines. So this is the block diagram of 4x1 multiplexer. One of these 4 inputs will be connected to the output based on the combination of inputs present at these 2 select lines. So we have 2 select lines, then we have 4 possible combinations. So one combination of the select line will be used for D0 to route D0 to the output Y. Second combination will be used for D1 to route D1 to the output line Y, and the third combination will be used for D2 to route D2 to the output Y, and to connect D3 we will use the 4th combination of S1 and S0. This is what the table of 4x1 multiplexer. So these are the 4 possible combination of these 2 select lines. This is the output. So when S1 and S1 is 0, is not at 0, so the output Y will be equal to D0. When for this combination, the output of S1 and S0, the output Y will be equal to D1, and for this combination of S1 and S0, the output Y will be equal to D2. The data of D2 will be routed to the Y output line, and for this combination of the 2 select lines, D3 Y will be equal to D3. Data and D3 will be routed to the output, so to this output. The Boolean expression for this multiplexer 4x1 multiplexer is this. so S1 and S0. So if both are 0 0, then y will be equal to d naught. All these combination other product terms will be 0 for if S1 and S0 both are 0 0. If for this combination y will be equal to d1, this will be 0, these two product terms will produce 0, and y will be equal to this term. And when as for this combination d2, y will be equal to d2 only, and for this combination y will be equal to d3 only. So this is what the implementation of the 4 into 1 multiplexer, realization of 4 into 1 multiplexer. So S1 S0, when both are 0 0, look, this is when S0 is 0, so the output of this inverter will be 0. When S1 is 0, the output of this inverter will be when S0 is 0, the output of this inverter will be 1. When S1 is 0, the output of this inverter will be 0. S0 is 0, the output of this inverter will be 0. So look, this is feed it to this gate where D0 is connected, and this is feed it to this AND gate. So this is 1, this input is 1 of this AND gate, and this is D0. So D0 ANDed with 1, so the output of this AND gate will be D0, and the output of these gates will be 0 0, and D0 plus 0 will be equal to D0, and the output of this OR gate y will be equal to D0. When S1 is 0 and S0 is 1, so this AND gate, this inverter will produce a 1, and a 1 is produced over here. So these two inputs of this gate are 1 1. All other inputs are 0 and 1 of other gates. So 1 1. So the output of this gate will be D1, and the output of, since S0 is 1, so the output of this inverter is 0. So the 1 input of AND gate is 0, so the output is 0. So the output of this gate will be 0. Similarly, S0 is 0, so the output of S0 is 1, and S1 is 0. So the one this is 0, so the output of this gate will also 0, and the output of this gate will be also 0. Only D1 for S0 equal to 1 and S1 equal to 1. The output of this AND gate will be D1, and the remaining 3 gates will have 0 output. And when it is applied to the OR gate, so this is 0, this is 0, this is 0, and this is D1, so the output y will be equal to D1. So this is this circuit is the basic implementation of 4 into 1 multiplexer. 8 into 1 multiplexer. So it has 8 input lines and 1 output line. So we can implement this 8 into 1 multiplexer like 4 into 1 multiplexer. We have 3 select lines. So S0, S1 is 2, and this is Y output. So this is what the travel for 0 0 0. When select lines are all 0, so Y output of this multiplexer 8 into 1 multiplexer will be D0. For this combination of input select lines, y will be equal to D1, and for this combination of select lines, y will be equal to D2. And for this, if the select lines have this combination for this state of select lines, output y will be equal to D7. So we can implement like 4 into 1 multiplexer. However, higher order multiplexers can be implemented using lower order multiplexers. So here we have implemented the 8 into 1 multiplexer using lower order multiplexer. 4 into 1 multiplexer. So this is a 4 into 1 multiplexer. This is another 4 into 1 multiplexer, and 2 into 1 multiplexer. So this is what a 2 into 1 multiplexer. We have seen the design of this multiplexer. It has 2 select lines. It has 2 select lines. The third select lines S2 is connected is to 2 into 1 multiplexer. So when S1 and S0 are 0 0, so D0 from here, this output will be equal to D0, and this output will be equal to D4. So if you want D4 to be appear on the output, so S0 will be equal to 1. So this 4 combination, these These D4, D5, D6 and D7, these four combinations are controlled by this multiplexer, and these four combinations are controlled by this multiplexer. And the set of these four should go to the output D0, D1, D2, D3. This is controlled by S2. When S2 is 0, so the output of Y will be either D0, D1, D2 or D3, depend upon S1 and S0. If S1 is S2 is 1, then D4, D5, D6, D7 will go to the output depend upon S1 and S0. If S1, S0 is 0, 0 and S2 is 1, then D4 will go to the output. If S1 and S0 is 0, 0 and S2 is 0, then D0, this D0 will go to the output. So this is implementation of 8-into-1 multiplexer. So we have used 4-into-1 multiplexer and 2-into-1 multiplexer. So higher order multiplexer can be implemented using lower order multiplexer in cascade. So this is the implementation, one of the implementation of 8-into-1 multiplexer. Demultiplexer. So demultiplexer basically this is the inverse function or reverse of the multiplexing. A demultiplexer basically reverses the multiplexing function. It takes digital information from one line and distributes it to a given number of output lines. For this reason, the demultiplexer is also known as data distributor. Multiplexer, the other name of multiplexer is data selector, and the other name of demultiplexer is distributor. Basically, a demultiplexer is a combination logic circuit which performs the reverse function of a multiplexer. It has single input, n select lines, and maximum 2n outputs. The input will be connected to one of these outputs based on the values of selection lines. So again, this is the 1-into-4 multiplexer. So the reverse function of 4-into-1 multiplexer. So look, it has a single data input, and we have two select line S1 and S0, and these are the four outputs: Y0, Y1, Y2, Y3. So with two select lines we have 2n4 output lines. So the demultiplexer takes data from this single input and distribute it to these outputs on the basis of these select lines. So if S1 and S0 both are 0, 0, then D will be routed to Y0. If S1 is 0 and S0 is 1, then the D data will be routed to Y1. So this is how demultiplexer works. These are the select lines S0 and S1. So we have four possible combinations, and these are the outputs Y0. So when S1 and S0 are 0, 0, so Y0, this will be equal to 1. Y1, for this selection we will have Y1, for this selection we will have Y2, and for this selection we have Y2. So D will appear on this. Y0 will be equal to D. Here Y0 will be equal to D. So look, Y1 is equal to D S1 S0. So when both are 0, 0, so Y1 will be equal to D. So if you put a D over here, so it will be more accurate. Y1 is equal to D S1 bar S0. So when S1 is 0 and S0 is 1, then Y1 will be equal to D. So this is the implementation of these of functions. So this is D, and this is S1 complement, and that is S0 complement. Please interchange these two symbols. S0, this is S0 and this is S1. Sorry, S1 and S0. So this is S1 and this is S0. So when both are 0, 0, so the output of this gate will be 0. The output of this gate will be equal to D. if this is 0 and this is 1, so the output of this gate will be equal to D, and if this is 1 and this is 0, the output of this gate will be equal to D, and if this is both are 1 1, the output of this gate y3 will be equal to D. So this D will be routed to y3, y2, y1 or y0. So D is, it depends upon this select line. So this is 1 into 4 demultiplexer, design of 1 into 4 demultiplexer. 1 into 8 demultiplexer. So for 1 into 8 demultiplexer we need 3 select lines, S0, S1, S2, and it can be implemented through a lower order demultiplexer. So in the first case we have 1 into 2 demultiplexer, so we have a single data input and S2. If S2 is 0, so the data will be connected to this D will be routed to this set of outputs, and if S is 1, so it will be routed to this set of outputs. And this is a, in this set we have S1 and S0, so S1 and S0 selects these output lines. The D output, the D this data link will be routed to one of these output lines decided by these two S1 and S0 select lines. So if S is 1, so this line will be equal to D. If it's 0, or sorry, S2 is 0, so this line will be selected. If S2 is 1, this line will be selected. So for this, look, for these 4 combination, S2 is 0, so these data y0, y1, y2 and y3 they are selected. So data will be routed to this line, and when S2 is 1, so this will become the D. The D will be routed to this line, and S1 and S2, S1 and S0 will decide to which output line will this data go. So this is implementation of 1 into 8 demultiplexer. So we have implemented it. We can implement it in like we have implemented 1 into 4 demultiplexer. However, this is if we know, if we have 1 into 4 multiplexers, then we can use it for construction of higher order demultiplexers. So this is about demultiplexers. This is all about for today's lecture. Thank you very much.